And we have reached the last section of this course, deployment. I'm going to show you how to deploy your application and your database. I'm going to show you how to store application settings in a secure way. I'm going to show you how to create custom error pages and how to log unhandled exceptions. So let's get started.
Deploying an ASP.NET MVC application is pretty easy. In Solution Explorer, right-click the project and go to Publish. Now we have this concept here called Publish Profile. So depending on where we're going to deploy our application to, we can create a profile that includes all the settings. With this, next time we want to deploy again, we can select the profile so we don't have to fill out all the settings again. On this page, you see we have 3 published targets. Microsoft Azure websites. So if you want to deploy your application to Azure, you come here. Now at this point, you need to log in. And then if you have any existing websites, they will be listed here. Otherwise, you can create a new website. Import is useful when there is an existing published profile you want to use. In the previous versions of Azure, this is how we used to deploy our application to Azure. So on Azure portal, we downloaded a published profile that included all the settings, and then we imported it here. And chances are some web hosting companies may give you a published profile. And here, the third option is used to create a profile from scratch. Imagine we want to deploy this application to GoDaddy. So we give it a name, GoDaddy Profile. Now on the Connection tab, we have a few different publish methods. The ones that you would probably use most of the time are FTP and file system. We also have web deploy, which only works if the target IIS is configured to support this. So it requires a few administrative tasks on the target Windows server, and with this, we can deploy directly to an IIS website. Web deploy package is similar to web deploy, except that it doesn't deploy directly to IIS. It creates a zip package that can later be used by a different process to deploy to IIS. But again, the target IIS should support web deploy. Honestly, I've never used this because in all places I have worked, we either used FTP or had our own custom-made deployment tool, so I had to publish the project on the file system. So let's select file system. I'm going to set the target location. Now on the settings page, we have this configuration drop-down list with release and debug. Now if you're deploying to production, you should use the release mode. Now later in this section, I will show you how to create other configurations. For example, specific configurations for your testing or staging environments. And then they will be populated here. So let's imagine we want to deploy this application to production. Now note that here, under databases, we have this message, database publishing is not supported for this publish method. But if you go back to the Connection tab and change the publish method to web deploy, we get this checkbox, execute code first migrations. With this, when your application starts up, it automatically runs all your pending code first migrations on the database. So no matter what version your database is at, it will be automatically migrated to the latest version. Now this is a great productivity booster because you don't have to do anything extra for deploying your database. But not all teams are comfortable with this approach. In a lot of places, you have to create a SQL script to migrate your database, and then either give it to a DBA who's responsible for that, or import it into an existing homemade database deployment tool. So I'll cover that in the next lecture. Now back to the Connection tab. Let's put this back on file system. And finally, publish. In the output window, we can see the progress of the publish wizard. So, site was published successfully. Now in the target folder, we've got bin, which includes the assemblies for our application. So we've got AutoMapper, Entity Framework, Glimpse, and a bunch of other assemblies, including Vitly, which is the compilation of our C# code. In the content, we have all the style sheets, fonts, scripts, and views, plus the favorite icon, global ASAX, packages config, and web.config. So these are the files that we need to copy to the target folder on our web server. Next, we look at publishing the database. So unless you're using web deploy and running code-first migrations as part of your deployment, you have to deploy your database manually. In Package Manager console, we can type update database and then provide a switch script. With this, instead of updating our database, we'll get a SQL script that includes all migrations in our application. So this is useful when you want to deploy your database for the first time. But after that, you don't want to run all these migrations again. In that case, you can provide another switch, source migration, and here specify the name of the migration class. For example, imagine we have run all these migrations from the beginning up to here. So in the new version, we want to deploy from seed users to the last migration. And here, we add seed users. Now look, here's a SQL script that we can hand off to a DBA or manually import into a custom database deployment tool. Once again, I want to emphasize the beauty of the code-first workflow. These migrations we have here include both our schema and data changes. So if as part of deploying a new version, we have to add new reference data, or modify or delete some of the existing reference data, they're all included in our migrations. If you don't use code first, you have to manage all these scripts manually, and from experience, I'm telling you, this is very time consuming, and actually it's a waste of your time because of the technologies we have available these days. So don't go back to the old way of doing things. Now, how do we know what migrations we have run on a given database? It's pretty easy. In our database, we have this table, underline migration history. View data. Let's expand this column, migration ID. So you can see the last migration run on this database is add number available to movie. So imagine all your databases, development, testing, staging, production, they all have a proper version history. You know exactly what version a given database is at and what you need to do to bring it up to the latest version. So that's all about migrating database. Next, I'm going to talk about build configurations. Okay, imagine we want to create a build configuration for our testing or staging environments. In these environments, we probably have different settings. For example, connection strings can be different. Our application settings can be different. We may use a different mail server or a message bus and so on. So on the toolbar, from this drop-down list, select Configuration Manager. And then in this drop-down list, select New. So I'm going to create a new build configuration for our testing environment. Now we can copy settings from an existing template. I would suggest for any of your environments like testing, staging, and production, use the release build. And leave debug only when you're developing. So use it only on your development server. Okay. Now that we have a new build configuration, if we go to Solution Explorer and right-click web.config, we see a new item here, Add Config Transform. See what happened? We have a new config file. So we had web.debug, web.release, and now we have web.testing. So as an example, we can get this connection string here and put it out of the comment. And this way we can overwrite the connection string to our database. So first of all, I'm going to change the name to default connection because in our parent web.config, here's the parent web.config. This is the name we use for our connection string, default connection. Now back here, you see here we have a different connection string. So data source is release SQL server. So when we deploy our application, this configuration will transform our parent web.config. So here we can add any other settings that are specific to our testing environment. Now let me show you a demo. So I'm going to save this file. Remember the connection string is pointing to release SQL server. Now, in Solution Explorer, I'm going to go to the Publish wizard again, Profile tab. Look, first of all, we have an existing profile. Now I'm going to create a new one. Testing. Change the publish method to file system and location to testing. Now in the settings, in the configuration, we have a new item. So I'm going to select this. And now let's deploy. Okay, beautiful. I'm going to bring up the deployment folder. I'm going to bring this web.config in Visual Studio. Here's our connection strings. Look, default connection, and it's pointing to release SQL Server. So this is how build configurations work. And finally, before we finish this lecture, in Solution Explorer, if you open Properties, under Publish Profiles, you see we have two different profiles. So imagine this is for our production deployment, and this is for deploying to the testing environment. So both these files are just XML that include the settings for each deployment environment. And when you check all this into your source control, all these published profiles are available to all developers in the team. So next time someone wants to deploy, they just go to the Publish wizard and select the right profile and then do the deployment. Next, I'm going to talk about custom application settings. In most, if not all applications, we have one or more settings that can impact how the application operates. For example, our application may use a mail server to send emails. So it needs to know the address of the mail server, as well as the username and password. As a best practice, we should not store these settings in the code. Instead, we store them in a configuration file. And that's where our web.config comes into the picture. So here in web.config, we have this section called App Settings, where we can store application settings using key value pairs. By default, we have 4 settings here, which are basically there because of the legacy stuff in ASP.NET MVC and how it has evolved from version 1 to version 5. For example, we have settings for enabling client-side validation or unobtrusive JavaScript. You don't really need to touch any of this stuff as they're used internally by the MVC framework, so just leave them the way they are. Now let me show you a real-world example of using application settings. Earlier, we added this app ID and secret for Facebook authentication. These values are hard-coded here, and that's not a good thing. So I'm going to move them to application settings. Back in web.config, I'm going to add a couple of keys. Facebook app ID. Set it to 1, 2, 3, 4, 5. Duplicate Facebook app secret. And set it to A, B, C, D, E. Now back in our startup class, to read the application settings, we use the configuration manager class, which is defined in system.configuration. So you need to import this namespace on the top. This class has a bunch of static properties and methods. Most of the time, we work with app settings or connection strings. So app settings. Now this is like a dictionary. So we can provide a string indexer. Facebook app ID. And similarly, Facebook app secret. Now in this case, both these values we're interested in are strings. But if you want to store numeric or Boolean values or date times in application settings, you need to convert them to the corresponding type because app settings always returns a string. So this is basically how we work with application settings. Now let's take this to the next level. Back in web.config, I'm going to add another setting, mail server. This is just for demonstration. We are not going to send emails. And I set this to dev-smtp.vidly.com. Now let's say in our testing environment, we want to use a different mail server. That's where our build configurations come into the picture. So we go to Solution Explorer, expand web.config, open web.testing.config. Now here, we add the app settings section. Now I'm going to go back to the original web.config, copy this setting, back here, and paste it. Now, if I leave it like this, it's not going to overwrite the setting in the original web.config. we need to apply a transformation. And for that, I'm going to borrow this line from connection string section. So this transformation says, when you find an element with the same name attribute, set all the other attributes based on the values in this file. Now I'm going to change this to key, because here we're using key. With this transformation, an application setting in this file with the same key will overwrite the one in the parent web.config. Now let me show you a technique. We can always preview the output of this transformation. So in Solution Explorer, right-click web.testing.config and select Preview Transform. So on the left, we have the original web.config, and on the right side, we have the transformed web.config, which is for the testing environment. You can see we have two changes here. One is for the default connection. If we scroll to the right, look, this value, the connection string on the left side, is replaced with the one on the right side. We also have another change, and that's for the compilation section. So debug equals true is removed. But note that our application setting, mail server, is the same. It's not changed. So we go back to our web.testing.config and change this value to test-smtp. Now save. We have to close the preview window and open it again. There you go. Now we can see our mail server setting in the testing environment equals this value. So this is how we work with application settings. In the next lecture, I will talk about securing application settings. Okay, now I'm going to show you a security risk with these application settings, and then I will explain how to address this issue. But before we get into the details, I want to emphasize that this approach has complexities, and I would recommend to use it only if you're working on a project where security is a big concern. Otherwise, keep things simple. So what's wrong here? We are storing this Facebook app secret as plain text. Also, in the connection string section, we don't currently have a username and password, but in most real-world applications, you would most likely have a username and password here. When we check this code into our source control repository, these secrets are visible to anyone who has access to that repository. And this is especially a big concern if you're using a public repository like the ones on GitHub. So we need to exclude these secrets from source control. Instead, every developer will have them on their machine, and when a new developer joins the team, someone in the team will send him the secrets internally. Okay, now let me show you the steps. In Solution Explorer, we right-click the project and add a new item. In the templates under Web, we select Web Configuration File, give it a name, app-settings.config, and make sure to select config here. Don't use XML, because by default, IIS does not serve configuration files. Now we delete everything here, go back to web.config, select app settings, cut, and then paste it here. Save. Now back in web.config, we add app settings again, but this time we set the attribute config source. And here we specify the name of the external file, app-settings.config. Now from source control management perspective, we can exclude this file, app-settings.config, from source control. And this will prevent the issue I talked about. But once again, do this only if you're using a public repository. If you're using a repository internally and only a few people have read access to that repository, you don't really need to do this, unless you're working on a project where security is a big concern. And by the way, you can repeat the exact same steps with the connection strings. So you create a separate file, move all connection strings there, and then set config source here. Now, in terms of deployment, when we deploy our application using the publish wizard, these external config files will also be deployed with web.config. Now, there is another risk here. On the target web server, these configuration files include our secrets in plain text So if a hacker gets access to this server, he or she can find all our secrets and get even more access. Potentially, they can get full access to the database and read a lot of private data or just execute a script to mess up with the data. To prevent this, we need to encrypt these files. Now, I'm going to show you a simplified version of this process so you see how everything works. But in reality, there is a bit more complication to this, and I will explain that later. So let me show you the workflow. Let's say we are ready to deploy our application. First, we go to Publish Wizard and deploy to the file system. So currently, you see I'm deploying to C drive in the deploy folder. Publish. Okay, beautiful. Now, before uploading these files to our web server, we need to encrypt our settings. So we search for Visual Studio Tools. Open this. Here we have developer command prompt. Right-click and run as administrator. It's very important to run this as an administrator, otherwise it's not going to work. Here we're going to use one of the tools with .NET Framework. ASP.NET _reg_IIS. We provide a switch -PEF, and this is for encrypting the settings. Now, we want to encrypt the app settings section in web.config. Now, in the real world, you would repeat the same step with connection strings as well. Next, we specify where our files are located. In C drive, in the deploy folder. So our web.config is here. And now for demonstration, I'm going to supply a provider. So prop switch, and I set this to data protection configuration provider. With this provider, only the machine that encrypts our web.config is the one that can decrypt it. This doesn't work in your workflow because you're going to encrypt this web.config on your build machine and then deploy it to a different machine. Then you would use a different provider called RSA. And for that to work, you need to create a digital certificate and share it between these machines. Then any machines with this certificate can decrypt this file. But again, that's really beyond the scope of this course. So basically with this command, we're telling the framework to encrypt the app settings section of web.config. Now, if the app settings section has the settings internally, they'll be encrypted there. Otherwise, if they're stored in an external file, that external file, in this case, app settings.config, will be encrypted. Succeeded. Let me show you the output. So here's my deploy folder. I'm going to open up this app settings.config. Look, this is the output. So if anyone gets access to this web server, they cannot extract our secrets here. Now, even though our app settings is encrypted, ASP.NET MVC runtime can decrypt it and extract the values. Now, let me show you how to decrypt this. So back here, I'm going to bring up the last command and remove the provider. And then change PEF to PDF, decryption. Succeeded. Back to Visual Studio. Yes. And here are our settings. So this was the workflow. You publish to the file system, then you use ASP.NET reg_IIS to encrypt app settings and connection strings. But as you see, this is manual and time consuming. So in a real world project where you need that level of security, you need to implement build automation. So you would create a script using tools like PowerShell that publishes the project to the file system and then encrypts app settings and connection strings. All right, we're done here. In the next lecture, I'm going to talk about custom error pages. Okay, let's see how to display custom error pages. So in this demonstration, in Home Controller, in the About action, I'm going to manually throw an exception to simulate a situation where we have an unhandled exception. Now build, back to the browser, and I'm going to navigate to home/about. So we get the details about the exception and where it happened. This is great for us developers, but we don't want to display this in production. First of all, because this would freak out our users. And also, it would add our application at risk in terms of security, because a hacker can try various inputs into our application to get an idea of how we have written the code. They can also find the version of .NET we are using. So we're using .NET version 4, and with this, they can easily do a Google search to find the vulnerabilities in this version. To solve this issue, in web.config, under system.web, I'm going to add a new element, custom errors, and set the mode to on. With this, we'll always display friendly or custom error messages instead of the exception details. We can also set this to remote only, and this means custom or friendly error messages are only displayed to machines that are connected remotely. But if you're browsing our application locally, like in this case, as a developer, I'm browsing this locally, I want to see the error details. So this is a better setting. But in this video, I'm going to set this to on because I want to enforce custom error pages so you can see them. Save, back to the browser, refresh. So we get this custom error page, which is more user-friendly and it hides the exception details. But where is it coming from? Let me show you. In Solution Explorer, under Views, Shared, we have this file, error.cs.html. And this is basically what you saw in the browser. Now you can customize this any way you want. But who is serving this view? We don't have a controller for that. That's where one of our global action filters comes into the picture. In filter config, remember this attribute, handle error attribute. This filter is applied to all controllers and all actions. As I explained before, action filters can be executed before and or after an action. So this filter is executed after an action, and if there is an unhandled exception in that action, it will catch it and then render that custom view. So that's how the magic works. So this is how we display custom error pages for internal server errors, which happen when there is an exception in our application. But there is another kind of HTTP error that we need to handle explicitly, and that's 404 errors, which indicate a given resource is not found on the server. So let's see a few examples of the 404 error. First, I'm going to navigate to a non-existing action, like home/about2. Remember the look and feel of this page. This page is coming from ASP.NET Framework, and we're getting this because ASP.NET cannot find an action that matches this URL pattern. Now, let's look at another example. In Customer's Controller, this is how we implemented our edit action. So if customer is null, we return HTTP not found. This helper method simply sets the status code of the response to 404. Now let's take a look at the result. So we go to customers/edit and provide an invalid ID. Note the look and feel of this error page. This is different from the previous one, right? Now this one is coming from IIS. So when the status code of the response is set to 404, IIS will generate this error page. Now let's take a look at the third example. I want to access a static resource, like image.gif. Again, we see the same IIS error page. But what happened to our custom error page? The custom error page, as I explained, is only rendered when there is an exception in our application. So the handle error attribute catches the exception and renders the view. But when we access a static resource like image.gif, there is no exception. In fact, this request didn't even make it to ASP.NET Framework. It hits IIS first, and IIS can tell from the URL pattern that this is a static resource, so it will not hand it off to ASP.NET. The same thing happens when we return HTTP not found. Again, there is no exception in our application. This method just sets the status code to 404, and again, the rest of the story is handled by IIS. So handle error attribute does not work in this case. And for this kind of error, we need a bit more configuration. Back in web.config, inside custom errors, I'm going to add a child element. Error, status code, 404. We want to redirect the user to this file. So in case you don't know, this tilde character represents the root of the site. So with this, we're telling MVC Framework that if it encounters a 404 error, it should redirect the user to this page. Now you might be curious, why are we redirecting to a static page instead of an action like this? Error not found. What's the difference? The difference is if something else happens in our MVC application, I'm talking about an error, troubleshooting that gets more complicated. So in these situations, when there is a 404 error, it's best to get out of the ASP.NET Zone and serve a static file. Also, this makes deployment easier. So if you want to change this static file, we can deploy it individually. We don't have to compile and redeploy the entire application. So I'm going to create this file. In the project root, add HTML page 404.html. I'm going to keep it very simple and just add a heading, not found. Back to the browser. I'm going to go to a non-existing action. So home/about2. Okay, look, now we see our custom error page. What if we hit a static resource, image.gif? What do you think is going to happen? Well, as I explained before, because this is a static resource, this request will not make it to ASP.NET runtime. So it's served by IIS directly. And that's why we get this error page, which is again a standard IIS error page. Now to change this, we need to supply a bit more configuration. So back in web.config, we scroll down and inside system.webserver, we can add configuration for IIS. So here I'm going to add HTTP errors and set the mode, error mode to custom. And that means we want to display custom error pages at all times, both for local and remote clients. If you want to display this only to remote clients, you can set this to detailed local only. But in this video, I'm going to set it to custom because I want you to see it. Now, first, we need to remove the standard error page. So remove status code 404. And then we add another error page. Error, status code 404, path 404.html, and we set the response mode to file. This is very important. If you use any of the other settings, the status code will be changed from 404 to 200. So from the perspective of the clients, they don't get the actual 404 error. And this is bad for search engine optimization. So we set this to file, save, back to the browser. I've opened the Chrome Developer Tools in the Network tab, refresh the page. Look, we get our custom error page, and look at the requests. Status code of the response is 404. So this is what we want to return to our clients. All right, this is all about custom error pages. In the next lecture, I will show you how to log unhandled exceptions in your applications. So to log unhandled exceptions, we're going to use a very popular package called Elma. In Package Manager console, install package Elma. Elma stands for Error Login Modules and Handlers. The way it works is that it plugs into the request processing pipeline, and if there is an unhandled exception, it will grab its details and store it. By default, it stores these details in the memory, but with a small configuration, you can have it store exceptions in different kinds of databases. Now let's see this in action. Back to the browser, I'm going to go to home/about to throw an exception. Now for your information, I've changed the custom error settings to remote only, and that's why you're seeing the exception details here locally. But let's say we have deployed our application to the production, and a few exceptions have happened here and there. To see these exceptions, we can navigate to elma.axt. So Elma registers this endpoint, and when we hit this endpoint, we see the exceptions Elma has captured. So we can see the host, the type of the exception, the error message, the user who got that exception, as well as date and time. Now here's the beauty. If we click on this link, details, we see a page that simulates the yellow screen of death. So we can see the exception message, as well as the stack trace. In this case, I can see that this exception happened in the About action in Home Controller on line 19. And if we scroll down, we can see server variables at the time the exception happened. So all this data help us troubleshoot the problem. Now, a couple of things here. First of all, this endpoint lmod.axt is only accessible locally for security reasons. When you deploy your application and you want to access this remotely, you need to do a bit of configuration. In web.config, search for lmod.axt. You see this location element. And inside this location element, we have the familiar web.config structure. So we have system.web. Inside system.web, we have HTTP handlers. So lmod registers a handler for this path, lmod.axt. So when we hit that endpoint, this class, error log page factory, is executed. This class is essentially an HTTP handler, and it's similar to an action in MVC. But unlike an action, it's not part of a framework. It's a class with one method that gets the request and returns a response. And it's a very low-level way of processing requests. And these days, having frameworks like MVC, you don't really need to create HTTP handlers unless you want to create a framework. So moving on, we have this section, authorization. I'm going to take this out of the comment. Now with this code, we are authorizing anyone who is in the admin role to access this endpoint. And we are denying all other users. We can also change this to users. So if there are specific users who can access that endpoint, we can add them here. For example, admin@vidly.com, comma, other users. Now, when we save web.config, our web application is restarted. And because by default, lmod stores exception details in memory, our log will be cleared. So when we get back here, look, there are no exceptions. So have a look at the lmod documentation to find the configuration you need to add to store the exception details in SQL Server. lmod also has a few other useful features. For example, you can configure it to send emails when it logs exceptions. But I leave all this to you as additional reading. So remember lmod? Use it, it's a great tool. All right, we're almost near the end of the course. Now, before telling you what is next and giving you some challenges, I thought to finish this course with a bit of art and creativity. So I have tweaked the styles of our application, and here's the end result. I think this looks better and more professional than what we previously had. Now I'm going to show you how I came up with this theme, but I'm not going through every little detail because it would just waste your time. Instead, I will just show you the workflow. If you want to see the exact changes I've made, you can look at the commit on GitHub. Also, if you like this theme, you can download the CSS I've attached to this lecture. Now let me show you a few simple techniques to improve the look and feel of your applications. Let's say you want to change the color of the navigation bar. Right-click here. Inspect. On the left side, you see the element currently selected. And on the right side, you see the styles applied to this element. Here, scroll down until you find the background color. Now, in this case, you are not going to see the background color because this style is not applied to the currently selected element. So you should look at its parent. In this case, container. If you look at the styles for this element again, you're not going to see background color. So you should look at its parent again. In this case, navbar-inverse. And here you see we had this background color and border color. But if you scroll up, you can see they have been overridden by these styles here. So currently you see these styles are coming from my Bootstrap theme, which is called bootstrap-theme.css on line 21. Now to change this color, click this box here and use the color wheel. And the rest is just creative process. So for every element, you can inspect it, find the styles, change the color, change the padding, change the font size. And as you're making these changes, save these changes in a separate CSS file. Do not change the original Bootstrap, because if in the future, Bootstrap team release a new Bootstrap and you add that to your project, all your changes are gone. So that's why I've created this bootstrap-theme, which overrides the styles in Bootstrap. For example, you can see that I have changed the text color. I've added a bit of margin below the headings, and so on. And of course, as you might guess, I've added this CSS in our bundle. Now, if you don't know what color to choose, your best source is color.adobe.com. Here you can find some really interesting color palettes. So here's the one I have used in Vidly. So I came here, I like this pink, I selected it, found the hexadecimal color code, copy, back here, and simply pasted that here. And then I use this green as the highlight color. So in our type ahead, let me show you one more time. This is the green. And I use this gray for our buttons. Here it is. So this is just a matter of experimentation and trial and error. There is no right or wrong. You just need to play with various styles to get a nice look and feel. So if you made it this far, you have proven your passion and determination for learning, and I'm sure if you constantly learn new things, you will have a lot of success ahead of you. Before finishing this course and telling you about the next step, I want to say thank you for allowing me to be your instructor and following the course all the way through. So in this course, we covered all the features of ASP.NET MVC, and if you have done all your exercises, I believe you should be able to apply what you have learned here in the real world. The more you practice these materials in the real world, the better you will get at them. So I've designed a number of challenges for you that you can see in the attached PDF. I've ordered these challenges from easy to hard, so make sure to complete them one by one. Also, I'm planning a follow-up course on ASP.NET MVC called Architecting and Testing ASP.NET MVC Applications. In that course, our focus will be purely on architecture and unit testing principles. So I will talk about topics such as dependency inversion principle, dependency injection, onion architecture, repository and unit of work patterns, programming with interfaces, and so on. As a case study, we will refactor our existing application and implement a clean architecture that is loosely coupled and testable. This will also improve the separation of concerns and maintainability of our application. So you will see how I will refactor our fat controllers and spaghetti JavaScript code into a properly structured and modular code. I cannot tell you exactly when I'll be publishing this course, but this will definitely be out sometime this year in 2016. If you'd like to be notified about this course and get it with a discount, please join my mailing list. Also, as soon as you join my mailing list, you will immediately get an email which includes coupons to all my other courses with up to 50% discount. I will not spam you, and you can unsubscribe at any time. I wish you all the best and hope to see you again.